Okay, it is going. Okay, morning guys. Happy New Year. And hopefully things on the admin side will be sorted out in the next week. That we can chat about that. But in the meantime, I thought let's just start with exam prep in any case. So that if the guys that need it, that we can just continue with that. So basically today, I think we start with study units 1 to 3, get into it, and then next week and the week after we can get into the more heavier things of the other study units. Okay, I need to change some of the settings, but I'll admit the people as they are joining the session. Okay, cool. So let's start. And as I said, we'll keep the admin for next week when we hopefully have more information about that, or we can have a quick chat about what we know after the session. Okay, so what I thought was, again, let's just do a quick summary of what we need to know. I'll also share again a summary page. The one thing that we now do know is that it will be on that you need to use Iris. It still means you are open book, so that is not changing, but you will need to use Iris. So okay, so in study unit 1, 2, and 3, the basic things that is important for us to know and understand and need to nearly have in our mind when we look at it is that we're going to do a few things in study unit 1. We start to understand what stats is. Then we go into the measurements. The other thing that they talk about in study unit 1 and 2 is the types of measurements. Then we go into some of ways of representing the data in study unit 3, in study unit 2, and then in study unit 3 we basically have ways to look at that data and use some calculations to describe the data. So basically study unit 1 is telling us what we are looking at. Study unit 2 is a visual representation of the data, and study unit 3 gives us some measurements around how we can interpret the data. And then obviously we go into the rest of the study units later on, about all the different methods of analyzing that data. Okay, so let's, and again, I think what I just want to go through today is nearly a reminder of the things that can be asked. This was out of, I think, one of your assignments last year. So just nearly going through the prep of that. So when we look at the exam, and you guys would have seen it now already, you nearly get 2 questions per study unit. Sometimes they do throw in a question that is nearly about 2 study units, but on average, 2 questions per study unit. Okay, so the first question that I want us to look at is basically um, what what if you look at the following statements, which one is correct? And you will remember from last year, um, again, there was a lot of the ones that said incorrect. So very important also just to, in the exam, once again, to really make sure that you read it correct. So do they want the correct one or the incorrect one? So which of the following statements is correct regarding some key terms in statistics? Okay, so let's go through them all and let's see what we have. A statistic is a measure calculated from a population. So what I normally look at is the statistic and population, is that the same? Um, so it's normally the statistic and a sample. So I think it is, so how I remember it is that in both is a S. Um, so a statistic is a summary measurement calculated from population. So it's incorrect because it is from a sample and not a population. But we are looking for the correct one. Okay, so a population is a set of all elements in a particular study. Okay, that seems that could be right. So a population is definitely a set of all elements in a particular study. If you're looking at a subset, then it would have been a sample. So that one is definitely correct. Let's just look at some of the others. A statistic is a property of a population. Statistic, sample, so no. A sample mean is a population parameter. Again, no, because sample is part of a statistic and not population. A sample standard deviation is population parameter. Again, no, because sample is with statistic. So for me, the easiest way always to remember this is sample goes with statistic. So the 2 S's. So the incorrect one was, sorry, and easy to make that mistake again. The correct one was a population is a set of all elements in a particular study. Okay, so that was nearly the beginning of study unit 1. I'll share again all of this and all the notes um, in the WhatsApp group. So don't worry about the notes and all those things. I'll share it in the WhatsApp group. I'm recording, so I'll share the recording afterwards in the group as well. Okay, so basically, again, something on statistics and population. So basically, looking at sample versus population again. Which one of the following statements is correct? Okay, so in this one, they were really on the idea of a correct thing. So very important again. So let's look. A statistic is a summary measurement calculated from a population. Incorrect. Okay, so statistic, like in the previous one, goes with a sample. And I will just nearly every time just write it down as so statistic with population. Incorrect. A sample is a set of all elements in a particular study. So very similar to the previous one. So a sample is a set of all elements, which is incorrect. It should be population. If we wanted it to be the sample, then a sample is a subset of all elements in a study. So if we wanted it to be correct, it should have said subset and not everything. Okay. A statistic is a property of a population. Again, statistic goes with sample, so it is not population. So look at that. So it's not the same. So it's a statistic is a property of a sample. A sample mean is a population parameter. Again, no. A sample mean will be a sample parameter or will be part of a sample. So it's not that. Sample standard deviation is a statistic. Correct. Okay, so sample goes with statistics. So I think that again is the important one. So in this instance, E was a correct answer. So also the reason again why I go through all of our options. Again, your exam will be scrambled the options. So there is again 3 different exam papers, 3 or 4 different exam papers. So questions very similar. Options will be scrambled. If there is data, the data will be different, but the questions on the data will be the same. So, but we'll get to some of those examples on data later as well. And just for the new people joining, we'll afterwards we'll talk about just a quick bit of admin, and hopefully by next week we'll know exactly where we stand with the exam. Okay, but I'll take some answers afterwards. Okay, so next one. So now we've nearly identified what sample population, what the parameters is, what statistics is around that. Now we go into a bit of the variables. So now we go into variables. The 2 things about variables is we look at measurements, and we look at different ways of describing variables. So again, asking which one is correct. So let's look at the questions, and let's look at the options. Which of the following statements is correct regarding variables and descriptive statistics? Okay, so qualitative variables. Okay, qualitative variables use labels or names to describe attributes of elements. Okay, so qualitative variables use labels or names to describe attributes of elements. I think that is correct, but let's just go through the other ones as well. Quantitative variables, quantity, Remember, qualitative is around names. So that's why that is actually correct. So let's just say from the start, it is correct. So qualitative variables are things like, if you want to use it in a sense of just normal quantitative, let me just rephrase, qualitative. So something like province is qualitative. Um, Something like your education level is ordinal, qualitative. So the important thing around some of these is also um, what type of measurement within it. So you will see it's the questions or the answers are also nearly scrambled into what different things were done in study unit one. So qualitative, it is around names, so variables uses labels or name to describe. It is correct, so that would have been the correct answer that we were looking for. Okay, so then the next one, quantitative. So that is something to do with quantity, with number of. So quantitative variables have either a nominal or ordinal scale of measurement, which is incorrect. Qualitative have a nominal or ordinal scale of. So quantitative, just remember always it, it's around quantity, so the number of people on the call, or the number of kilometers you have driven today, or the number of hours you had load shedding today. That is quantitative. Um, if and let's use, sorry for the guys that are from Eskom on this call, but let's use that same example of Eskom. How do you feel about the load shedding? Happy, sad, um, angry, furious, whatever, that will be then a qualitative, and that will be a ordinal because there's order in how you feel. Okay, measuring attributes of an element results in a quantitative discrete variable. Measuring attributes of an element results in a quantitative discrete variable. Wrong. Okay. If it's measuring attributes, you're looking at qualitative. Um, so it is not quantitative. Quantitative variables are also referred to as categorical. Again, qualitative variables are referred to as categorical, so not quantitative. So that is where the mistake is. The mistake in this one is if you're measuring attributes, you're also measuring qualitative. Let's go to option E, and let's just look at descriptive stats. Is the process of using data from a sample to make estimates and test hypotheses about characteristics of a population, drawing conclusions, a population-based on sample results. Okay, so what is wrong in this one? So descriptive stats is a process of using data from a sample. So that is up until there is correct to make estimates and test hypotheses about characteristics of a sample by drawing conclusions of a population based on sample results. So that one is the one that is wrong, because what you are doing is you're looking at the sample, you're drawing estimates on that sample to make a call on what happened in the population. So question or option E is quite interesting, because this is using study unit 1 plus nearly study unit, what is it, 6 and 7, with normal distributions um, and making decisions on hypothesis, which is 8 and 9 as well. So this is quite an interesting option, but at least it was the wrong option. Okay, so again, let's just do a quick check in how everyone is. Nearly getting remembering the stats again from last year, just getting into the flow. As I said, we'll manage the admin stuff afterwards. Questions on the first three that we've covered, or can we nearly go on? Okay, cool. That's a nice indication that let's go on. I'll share, as you see, there's question 3. I skipped to question 8, so I'll share the 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 other deck with you with more of the questions. The answers are also in the end of a question set, so or at the end of the deck. Okay, so let's look at question 8. We're still into types of variables, and again, which statement is correct. Okay, so refer to the scenario in the previous question. I'm going to quickly check if I can bring that in, what they were talking about. So let me just do that, and then so we're not doing question 7. I just want to sketch this scenario. So let's just, so we're not looking at that question, we're just nearly looking at what the information is. Okay, so the information talks about the majority of rural schools in South Africa are in the Eastern Cape, KZN, and Limpopo. The Department of Basic Education requires your assistance in gathering some of the information to effectively manage their scholar transport system in some of the rural areas. Okay, so looking at that, which of the following statements is correct with regard to type of variable. Okay, so the list of schools requiring learner transport is a qualitative nominal variable. Okay, so let's mark that. The distance from the learner's home to the school, quantitative, correct. Discrete variable. Okay, so what would you have said in this instance? The distance from the learner's school is a quantitative so this is taking you back way to the early part of last year. Okay, so the distance from a learner's home to the school, it is quantitative. Discrete is basically saying that you know it is 14.5, 14.6, or you exactly know what the measurement is. So I would say it is not discrete, but it is continuous, because for each learner it will be different, and it will be on a continuous interval or continuous path. If I said the distance in kilometers from the learner's home to the school, then it is quantitative discrete variable, because then you exactly know what the measure is, because then it can only be 19, 20, 21, or 100, or whatever. So again, important is merely to look at how the question is structured so that you can make a decision. Let's look at the next one again. Number of, distance of, all of that is quantitative. So that is not the problem. The number of learners at the school is a continuous variable. So that again now is where the problem lies. It's a discrete, because you can't get a number of learners that is continuous, because you don't have a half a learner, or a 0.25 of a learner, or 0.3333 of a learner. You only have discrete number of learners. But I think the important thing here is when you look at number of, then you know it is a discrete quantitative variable. So interesting in both of these, the quantitative was correct, but the one that was incorrect is there the discrete and here the continuous. So again, it's very important in the exam to see which ones where is, because half of it is correct and the other half is incorrect. Okay, so let's look at the travel time from the learner's home to school. Okay, so that and that is very similar. Travel time, distance from So let's do it this way again. So it is quantitative, but it's not discrete. Um, because again, you want, if it's discrete, you need to know exactly what the time is. So then they should have set the travel time in hours, the travel time in minutes, um, the travel time in seconds. All of those things will be in the identification of discrete. If they only tell you travel time, then we assume it is continuous. So again, quantitative were perfectly correct. The one that is the incorrect one is to say that it is discrete. But B and D, you can see it is looking at nearly exactly the same type of question. They need to say for those two if it needs to be continuous or if it needs to be discrete, like they ask, they need to say for B the distance in kilometers, and for time they need to give you a measurement. So the travel time in seconds, minutes, hours, days, whatever. Okay. Then let's look at E. The level of schools, primary, junior, high school, regarding transport is a qualitative nominal variable. Okay, so let's look. Qualitative, again, is correct. Nominal is which province do you live? Um, there's no order in it. It just nearly group you into that qualitative variable. So nominal refers to grouping you into a group, but there's no order in it. Here we're talking about primary, junior, and high school. So we know primary, when you go into junior, when you go into high school. So there is order in it. So that should have been ordinal. Um, so qualitative is still correct, but it should have been ordinal. So qualitative ordinal variable. So that is where the problem lies. Um, so also incorrect. So let's look at that first one again. A list of schools requiring learner transport is qualitative. Yes, because you get a list of names. Nominal, yes, because there's no order in it. You just get a list of names, so that's qualitative nominal variable, which is correct. Okay, if I said the list of schools requiring learner transport or a list of schools, primary, junior, high school, um, then again we add ordinal or order to it. At the moment, that is just basic. There's no order, just a list of names, so it is nominal. Okay. So you can see this is quite I think a difficult question, as it takes into account your study unit one, both the measurement and types of variables. And I think what is more important in this one is that all of them, the first part of the questions were right. So all of them identified that it was quantitative. Those three were all quantitative, which is correct. that was qualitative, which was correct. So the type was right, but then your measurement within it was wrong. So I think again for the prep for the exam, very important. Nearly this question, I think it's a very nice question, nearly to get your head around. So this for me is a very nice one to to nearly go through again, because it really covers those two things within the variables quite nicely. Okay, so let's go to the next one. So this you'll also see in your papers, and it's always dependent on how they want to show it. If they give you numbers, if they give you names. Normally in the exam it's less, so that you can nearly have, what do we call it, um, less of data, because I think that is always the interesting one, um, that the more data, the longer you normally take on things. So in the exam, definitely again, and I think that was like the previous exam as well, when we look at data, it will be less if you need to analyze a set of data. Okay, so let's look at this. Let's look at the question. A recruitment company asks job seekers about their preferences, i.e., whether they prefer to work remotely, office-based, blended setup, or if they would rather have a 4-day week. Okay, so the data is below, and they tell us it's 70 job seekers. So what they do is give you the data, and then they ask you to say which one of these graphs are the most likely one, for the data. Okay, so if I just look at this. So they use the percentage a lot, but they don't use it in all. So that tells me, okay, if I work one of the percentages out, I might be able to cancel out some of the options. So firstly, I will not do all of them. So I will not go and type all of this in. I know there's 70 job seekers. So I would say, okay, let's look. There's a lot of blended, there's a lot of remote. Like me, there's not a lot of office. So let's count how many office, and then we see if we can at least eliminate some of the office. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of your 70 is office. So let's get that bit presentation. 10 out of 17, so it is 14%. Okay, so that is for office. Okay, so there we don't know yet. We could add those together and get that one, but let's say we're going to work one of the others. 14 correct, 14 correct, 17 incorrect. Option A is not an option. Okay, then feels to me the 4-day week, is the next one that we can count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 out of 70. 17 divided by 70 is 24%. Okay, so there's a 24, not 26, and that one is not stated. So we are sitting now with two different options here. Here we can see 32 and 50, 50 and 27. Okay, so one of those we need to calculate. Let's just do blended because that's the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then up until there, it will be 20 and 21. Okay, 21 divided by 70 is 50%. So blended is 50%. It is not 27. So there we have option B as your correct option. Okay, so you could also go and work out remote. It will be, if you count it, can count it, I just would have said 70 minus the rest, which is 22. So 22 divided by 70 would then give you, that is quite interesting. That gives you 51%, unless I now made a mistake. Okay, so that, sorry, I'm just muting. Okay, so the last one, that is quite interesting, because if I do that calculation, it gives me 51 and not 52. Okay, but see there, it's rounding it off, because 4 plus 4 is, so that is 58, 68, so it needs to be 52. Okay, cool. Okay, so that is, if you get a set of data, this data can be quantitative, where they give you numbers. It can be that this is something that they also do a lot, is to give you what types of newspapers or what types of movies or all those kind of things you like to watch. So so this is quite um, a question that they use a lot. The data will just be different. So again, between the 3 or 4 different papers, what will happen is that this set of information will be different, so that your answer set will be different. So it might be that now office in another question is 20, and blended or 4-day is 11 or 12. So just again, how it will differ between the papers is the data set will be different in how many, so that your graphs will look different, but it will be the same question. Okay, and as I thought, okay, so let's go into a group of data. The data below shows the daily electricity consumption for 50 randomly selected households. Use 15 as the lower class limit of a first class to construct a histogram for daily electricity consumption with 6 classes. Okay, so let's then see what is. So with X as the upper class limit of a third class, what is the relative frequency of class 727 to X? Okay, so let's look at this one, because I don't even think there would have been something like this previously. So let's just use 15 as a lower limit of a class. Okay. They tell us there's 6 classes. Do they tell us? They just tell us that is upper limit for class 3. So the data below shows the daily 50 random. Use 15. So 15 we'll use as lower class. They don't tell us what we need to use as for upper class. So then we use 46 as the upper class. Otherwise, they needed to tell us a number for that. So 46 divided by 15. Sorry, let's do that first. We use that as the lower, so that is 30 divided by 6, because they told us 6 classes. Okay, so the number of um, of people or households per class. Okay, that can't be 5, so it is a class with, what do you, I normally can't pronounce it, the class with or width is 5. So you will start with 15 to 20. So that's 5. That's 5. Remember, we start. They told us to start at 15. We add 5 to get the 20. So the next one, because it's discrete, we start at 21. We don't start at 20 again. 15 to 20, 21 to 26, 27 to 52, 53 to plus 5. I hate it when it's not rounded numbers. I love to work with rounded numbers. 44, 1, 2, 3, 4, 5. So last one will actually be to 50, even though there's only one number in it. Okay, so let's then count, because they want relative frequency. So this is quite interesting. So we're not asking for that value. That value we now know is 32. That's the upper limit. So they're not asking that. They're asking for what is the relative frequency of class 27 to 32. Okay, so we first need to count how many is in each of the classes. So for the first one, 16 to 20, we've got 3. 21 to 26. Yo, okay, wait. Just putting that in. That's that's a huge one. Just want to make sure I count correctly here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, it's just do that, because that will be your relative frequency. Okay, let's look. It's 27 to 32. That's another color so that we can 27 to 32, including 52. Sure. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 18. I get 18. 18 divided by 50. 18 divided by 50 is 0.36. Okay. If I ask us cumulative relative frequency of that same one, it would have been 3 plus 12 plus 18 divided by the 50. Okay, so if it was cumulative, it would have been 3 plus 12 plus 18, which is 53 divided by 50, which would have been 0.6, because they, or 66, so they can ask cumulative as well. If they've asked a percentage, we multiply that by 100, so that it would have given you 36%. If it was the cumulative frequency percentage, would have just multiplied by 100. Okay, so this is not one that I've seen really before. What they would normally do is stop at you calculating the x. So now they went further by looking nearly at cumulative relative frequencies. So it might even be that the next one is cumulative. No, so let's quickly just have a check-in at this point. Again, for the guys that joined during the process or during the session, we'll talk a bit admin just after the session. So if there's any questions on the questions, ask, but we'll do the admin a bit later on. Okay, so let's then continue. So what we also have in the first pre-study units is obviously we now have done the types of variables. We've looked at how you can visually represent it. Now the next set is nearly to say, okay, but now you can describe that as well. So consider a sample of size n is 13 observations. In an ordered array of these observations, which one of the following statements best describe how to determine the quartiles of the sample data? Okay, so let's write it down. Let's do this. Let's just make it, I'm gonna do it the other way around, that I have enough space. So we've got the 13 observations. Okay, so the first quartile is given by observation 3, third by observation 11. The first quartile is calculated at the average between 3 and 4. The third quartile is calculated as the average between 11 and 14. The second quartile is given by observation 8. So let's look at this and see what is the options, or what is the best. So second quartile is the one in the middle. So the second quartile is the same as the median. Okay, so the one in the middle of 13 observations, so there's 6 on the one side, there's 6 on the other side, so your median is in the middle. It should be 7. The second quartile is given by observation 8, so we know that one is wrong. Consider a sample in an ordered array of which are one of the following statements best describe how to determine. Okay, so best describe. So okay, so that one we've cancelled, but it's not what we're looking for. Okay, so here we're talking first quartile, third. So okay, we need to work out quartile 1, quartile 3. So how to work out Q1 is we use the formula that they provide us, n plus 1 divided by 4. N is 13 plus 1 divided by 4. So 14 divided by 4 gives us 3.5. Okay, the first quartile is given by observation 3. We're actually looking for slap bang in the middle of the two. So not that one. But let's work out Q3 as well, because we're still looking for the right answer. How I remember this as well, Q1, with a formula, we don't really write the one ever in front of it, but there's a 1 in front. So for Q3, there's also the 3 in front. So it's n plus 1 divided by 4. Okay, so we know it's 14. So 14 times 3 is 42 divided by 4. That gives us 10.5, 10.5. The third quartile is given by observation 11. We know it's between 10 and... Okay, so this is an interesting one, because we've learned that we round it off. So if we round it off, we would have said we round it off to 11, and then that is correct. But let's look at the other two. First quartile is calculated as the average between observation 3 and 4, 3.5. Average of 3 and 4, correct. The third quartile is calculated as average between 11 and 12. No, it's between 10 and 11. So that one is incorrect. Okay, so best describes, best is that it is in the middle at 10.5 and not 11. So that is why option C is the correct one. But D I'll nearly mark as also an option, because I know we've learned that you round off to certain numbers. So if that was 12 plus 1, if a sample was, what do you call it, even, then it would have been, we round it off, because then it would have been 10.75 or something weird like that. But because it's now with 14, it will always give you an even number between. Okay, so the best one is between 3 and 4. Okay, so that is more on the what do you call it, the definition part of how to calculate Q1, Q3, the median. Then there's also that we give or get the values. And again, it will be a small set. I won't give you, like in this instance, a big set to calculate the mean, or even this to calculate the mean. It will be a much smaller set. They don't tell me how much numbers, so I need to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at least we know n is equal to 10. This is not ordered at all, so let's order it first. So it seems like we're going from 32. Okay, so that's one of the 32s. There's another 32. There's another 32. So there's 3 32s. 33. 53. Okay, so it seems like the mode is going to be 53. Let's just, is it number 53? Invest 254s. Okay, so let's look at the number happening the most. That for me is always the easier one, and that is 53. So mode is 53. Okay, cool. So by getting the mode, we have eliminated 3 of the options. Okay, so then let's get the median, because the median is the one in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the one in the middle of those, so between 53 and 53, it needs to be 53. So the median is also 53. There we have it. So A is the correct one. So what we haven't even calculated the mean, which normally will take you longer. But if we calculate the mean, we can do that. You just add up all the numbers to get the sum of. So I'm just quickly doing that. So I'm getting the sum is 329. So the sum of all of the sum of those values is 329. If I divide it by 10, I get the 32.9, which was also correct in any case. So all 3 of them is correct, giving you the correct option. Okay, so again, shortcut, what I normally do is I look first at median and mode. And if there then is only one option, you can automatically don't even need to work out the mean, because you will have that answer. Okay, so let's go to the next one. So here they ask us, and you'll see that I haven't even brought out the Excel yet. Yeah, I would maybe start doing that. But also you can use your calculator. This one is an interesting one. So what is the value basically of a sum where you say that to the power of 2 plus that to the power of 2 plus. So you basically need to make that calculation. Again, as was said in the exams, it's open book. So you can use calculator, you can use Excel, you can just not use a friend to ask them. So you can calculate that on Excel. So I would have probably done it in Excel. So let me just see if I can quickly open that and just copy the question. Okay, so I would have just said, okay, that is X, that is what we're working with. 29, 30, 31, 31, 31, 33, 34. I'm not going to worry now in doing the sorting. I'll sort that out I'll sort that out while in Excel. 35, 36, 34. Okay, so that is all of that. Let's quickly sort it. Okay, there it is sorted. So if I want X, and I'm gonna write it is X to the power of 2. So you can actually use that formula, or you can just say that times itself. You will get exactly the same answers. Then we get to total. So let's just do sum of it. So if there was a question of sum of the okay, so there we have it as the first one. So we just basically, like I said, multiply and we need to add. So multiply, add all of them, and then our answer would have been option A. Again, exam, you will probably not get this bigger set of data. So if you get it, it will be smaller, but then you can rather use Excel or your calculator. You just need to make sure when you use your calculator that you don't skip a step or skip a number. But again, you can see it's big differences in the numbers. So if you skip one number, it will not be in a question like this. If you skip one number, there will not be an option for that. So you will just see that you don't match any of the numbers, but you will probably be close to one of them. See now, on the same data, they're now asking what is the value of xi minus the mean. So again, if we didn't have this, you would now have needed to, if you have a scientific calculator, it's easy because you can go and on a scientific calculator, you can go and ask it to, yes, I just need to say, you can go and ask to work it out. And just that is some. So on a scientific calculator, you can go back and there is options to work out the mean, and there will be an option to work out the other one. I just want to again just copy this in. I'll send to Excel to you as well. Okay, so let's let's do that formula. X minus, I'm just going to say mean, and to the power of 2. I nearly missed that. So let's first do that, and then we'll do this part here, so that at least whatever they ask you, you have the option. Okay, so X minus the mean, we've got that. That is quite interesting. That is definitely doing something wrong. That is quite, I will check why that is doing that. Okay, that to the power of 2. Okay, so we sit with the answer of 236.4, 236.4. So option E. This one should be, it's quite interesting why that is wrong. It should be equal to 0. So let's just take that out. We'll sort that out later. Okay, but there you've got with 236.4, which is option E. Again, calculator, much more difficult. There is settings to work it out dependent on which financial or scientific calculator you had. If you wanted to do it by hand, it would have been, what was your mean? 33.8. So you would have needed to say that plus, so that was that one, and continuous until you do 34 minus 33.8. If you have added all of that together, you will also get that answer. So you need to basically do that for that whole one. So again, lots of calculations where it is simpler to do it in Excel or a scientific or financial calculator. Okay, so again, same set of data, calculate the sample variance. So again, I'm just gonna add, I'll do it a bit cleaner when I send it on. Okay, so let's do sample standard deviation. Sample variance. And for these two, there is actually nice samples. Let's quickly see. Standard deviation is nice. So standard deviation of S variance, sample variance. Okay, so again, to save time, you can use the Excel for that. Sample variance, 16.89. If you calculated sample standard deviation, there would be an answer for you as well. If you calculated population standard deviation and population variance, there would be answers for you as well, I think. So let's see, standard deviation of population, the P. There's the answer if you were being asked that. Variance of population. And there is also an answer for you if you needed to calculate that. So again, it is in Excel. The problem then is that when you are in Excel, that you know which formulas also to use. So sample variance is where it would be interesting if I haven't seen coefficient of covariance. So we don't have coefficient of in one of the sets, but let's see again quickly. It is the same data. So when I'll send this to you, it will look a bit cleaner, that you can see all of the. So same set. Let's do coefficient of variation. Coefficient of variation. We have a formula for that. Can anybody remember what the formula is for that? Let me quickly check. Where's my notes? I can't remember the formula of that, but I have it somewhere. Coefficient of variation is your standard deviation of your sample divided by your mean. So you guys can see everything is in here, and you multiply it by 100. So you basically get the percentage. Let's just see, all of these are rounded off. 12.16. 12.16, there it is. Okay, 12.16. So again, I'll send this afterwards. I just want to make it a bit cleaner, but there is your coefficient of variation as well. So basically, depending on what you need, you can use the same data set for all of that. Okay, so I think let's stop here. Yeah, let's stop here. We'll do the other three next week. Let's stop here. Let's talk about about what's currently happening so that you just know what I've been told. I just want to quickly save everything just as study 1, 2, 3 so that I know it will be there. Okay, and for this conversation, I am gonna stop recording that Unisa don't get mad at me. So let's just do that.